Good morning, Madam Suhada. My name is Saran Kumar Analaki Siva Perkasum. My matrix number is 33 DCE 20F 2019. Today I am going to present my practical task 1, which is about tensile strength on mild steel. The objective of this practical task is to study the mechanical properties of mild steel specimen under tension load. The apparatus that we will be using for today is universal testing machine, dial indicators, extensometer, scale and vernier caliper. Let's begin for step number 1. Step number 1 is to measure the initial diameter of the tension test sample in two perpendicular directions using vernier caliper. Okay, the first value we get is 12.70 millimeter. The second value we get is also the same 12.70 millimeter, which makes the average initial diameter 12.7 millimeter. The next step is to measure the length of the specimen between the grips using a scale. This is the grips from this end to this end, and on the other side, this end to this end. The length that we want to measure is in between it, from here until here. The length between it is 200 millimeter as shown. The third step is to make punch marks at a distance of 2.5 diameter. We go 1, 2, 3, 4, 5. There's 5 punch marks in total. The next step is to insert the specimen into the position and mount the extensometer onto the specimen. First we release it, and then we drag the specimen onto it to make sure. Then we tighten it up again. Before starting anything, we have to make sure the readings on the dials A and B of the extensometer are adjusted to 0. This is to make sure there is no false reading. The least count of the extensometer is 0.01 millimeter. Step 6 is the experiment is conducted. Load extensometer readings are read at the regular intervals of load up to the yield point. Ivory scale readings are noted till the specimen failure. First we on the machine. After onning the machine, we will start to gather in and get in data, as you can see. As you can see, it's getting smaller and smaller until it breaks. Then we stop the machine. We can download the data if we want to, which we will. On to the next step is the graph. The relationship between this graph, on the y-axis is the load in kilonewton. On the x-axis is the ivory scale readings in millimeter. We can also view the data. Okay. On the next graph, we can see on the y-axis is the load in kilonewtons again, but on the x-axis is the extensometer reading. We can view the data. But most importantly, we have to view the slope, which is 2.21, as you can see here. Step number 9 is to join the two pieces of the test sample and measure the diameter at the neck of the experiment. Basically is we're going to combine the pieces and to calculate the final diameter. The final diameter is 7.28 millimeter. On step 10, we have to measure the final length between 3 punch marks. The final length between the punch mark is 83 millimeter. The observation and calculations, the first question is to find the yield stress. To find the yield stress, we have to use this formula. The yield strength point divided by the original area. To find the yield strength point, we have to go to the graph. At this curve, we have to see which is the highest at this curve right here, which is 44. And then to find the original area, we have to see here 126.61. So 44 kilonewton, once it's converted to Newton, it will become 44,000 divided by 126.61, which is the original area. We will get the answer of 347.5239. Okay, so we put the value inside here. 347.5239. To find the tensile strength, we have to first find the maximum load. The maximum load, you have to see the highest peak point, which is 56. Okay, 56 kilonewton is equivalent to 56,000 Newton. So 56,000 Newton divided by the original area, which is 126.61, we will get the answer 442.3031. So we will enter the calculation here, 442.3031. To find the modulus of elasticity, we have to use the formula of this. For this, slope is equals to 2.21. The least count is equals to 0.01. The gauge length is equivalent to 120. The original area is equivalent to 126.61. Okay. After this, we get the answer of 209.462. So we just enter the digit here, 209.4621. To find the percentage elongation, we have to use this formula, which is the final length minus the initial length times by 2 divided by the initial length times by 2, and then to find the percentage times another 100. The answer that we will get from this is 29.8905. For us to find the final length, we have to go here to the observation and see this is the final length. This is the initial length. Is equivalent to initial length times by 2 is equivalent to 63.90. After we calculate the percentage, we will get this answer. So we have to put it there. 29.8905. for the fifth question, we want to find the percentage reduction in area. Is we have to use the formula of original area minus the final area divided by the original area times 100 to find the percentage. So this is 126.61 divided by 41.6, minus 41.6, and then the answer of this will be divided by the original length, which is 126.61, and then times by 100 to get the percentage. So the total answer of this will be 67.1432. 67.1432. Okay. To find the final area of this, we have to go to the observation, and then we have to find the final area, which is this 41.61. So now we can check our result. You see, it's almost everything no percentage error. For clearer calculations, I will put into the next video. The next picture for all the clearer calculations. Thank you, madam.